Imagine watching the tiniest switches in the universe flip faster than anything you've ever seen. Now, what if that switch happened in just 140 trillionths of a second? This isn't science fiction. It's what scientists have actually captured happening inside a special magnetic material. And this one discovery could completely rewrite the future of computers forever. So, what exactly did they see? Scientists have just achieved something truly groundbreaking. They created the first clear visual record of how electron spins. These are the tiny magnetic directions inside. Atoms flip inside a material called an antiferromagnet. Think of it like this. In a regular magnet, like the one on your fridge, all the tiny magnetic spins point in the same direction, which is why it sticks. But in an antiferromagnet, the spins are arranged in a neat up-down pattern, so they cancel each other out. You wouldn't even know it's magnetic just by looking at it. But it's this unique property that makes antiferromagnets so exciting. They hold the key to unlocking ultrafast non-volatile memory. We're talking about technology that would be orders of magnitude faster than any computer or storage system we have today. This could mean computers that turn on instantly with no loading times and data storage that uses way less power. For years, there's been a big mystery in this field. When you send an electric current through one of these materials, the spins flip. But why? Is it because the current heats up the material and the heat makes them flip? Or is it something about the current itself directly pushing the spins over? This question has puzzled physicists for a long time. To finally get an answer, a research team led by Ryo Shimano at the University of Tokyo decided to watch it happen. They created an incredibly thin layer of a compound called manganese-3 tin, or MNYSN, which is a known antiferromagnet. Then, they zapped it with unbelievably short pulses of electricity. To see what happened, they used a clever technique. They fired ultra-fast flashes of light at the material, with each flash delayed by a tiny fraction of a second after the electric pulse. By piecing these flashes together, they basically created an ultra-slow-motion movie, a time-lapse sequence of the entire switching process. And what they saw was stunning. For the very first time, they witnessed not one, but two completely different ways the spins could switch. First, under very strong electric currents, they saw what's called heat-driven switching. The intense current generated a lot of heat, and this thermal energy was enough to jiggle the atoms and cause the spins to flip. This confirmed one of the existing theories. It works, but it's not the most efficient way to do it, since heat means wasted energy. But then came the real surprise. When they used weaker electric currents not strong enough to generate much heatless spins still flipped, and they flipped through an entirely different, much faster process. This was the direct, current-driven switching they were looking for. This second process is where things get really exciting. It's like discovering a secret shortcut. It airs a mechanism that could become the foundation of a whole new generation of technology called spintronics. Spintronic devices would be faster, more stable, and vastly more energy efficient than anything we use today. Think about it. A switch that doesn't rely on generating heat is a clean, efficient switch. The team managed to capture these changes happening at a timescale of 140 picoseconds. That's 140 trillionths of a second. To put that in perspective, in the time it takes you to blink, this switch could flip millions upon millions of times. And the scientists believe the material can switch even faster than that. They just couldn't measure it because their electric pulses weren't short enough. So, what's next? The team's next goal is to create even shorter, even faster electric pulses to push this material to its absolute limits. They want to find out just how fast these spins can truly be switched. This isn't just about answering old scientific questions. This discovery is cracking open a door to a whole new world of computing, communications, and advanced electronics. We're on the cusp of a technological leap, moving from electronics to spintronics, and it all started by watching the tiniest magnets in the universe do their dance. If discoveries like this excite your imagination and make you wonder about the future, then you are definitely in the right place. Drop a comment and let me know what you think this technology could be used for. Hit that like button if you learned something new, and most importantly, don't forget to subscribe to the Science Spark for more mind-blowing breakthroughs from the world of science. Thanks for watching.